is we're going to finish up the exponent laws and look at the other exponent laws that we covered in the grade 9 course. The first one is when you have a power raised to an exponent, and the fancy name for it, it's actually known as the power law. So you'll notice same chart setup as last lesson. So we have an expression, we're going to rewrite it as repeated multiplication and then clean this up to get power form and then try to see if there's a pattern that we're noticing. Now, the way this first one is written, so I have 2 to the power 3 raised to the power 2. So you can think of that, this is like you having 2 to the power 3 2 times. Okay, that's essentially what that means. Now, if I take this and break it up, well, 2 to the power 3 is like having 2 times 2 times 2. This 2 to the power 3 is like having 2 times 2 times 2. So again, I'll color code stuff. Sometimes makes it easier to see. So this one, repeated multiplication, is that part. This one, repeated multiplication, is that part. So if, again, ignore the expression, then in terms of how I could rewrite this piece as a single power, well, I know my base is 2, and I have 1, 2, 3, 4, 5, 6 of them. So I could write that as 2 to the power of 6. Next example, 3 squared raised to the power of 4. That's like you having 3 squared 4 times. So if I were to write out each of these parts separately as a really long repeated multiplication, it's going to look like this. So when I write this out, I have 4 of these 3 to the power 2, and then each of these I could break up on its own. So this became this 3 times 3, the blue, the green, and then the pink. So if I were to take all of these and try to rewrite that as a single power, again, the base I know has to be 3, and I have 1, 2, 3, 4, 5, 6, 7, 8 of them. So I'd say that's like 3 to the power of 8. One more, if you had, for example, 5 to the power of 4, and it tells you have that 3 times, well, that's telling you you have this, 5 to the power of 4, once, twice, 3 times. So then again, if I were to break this up, here's what I would get. So I end up with 1, 2, 3, 4 5s from this piece, 4 5s from the blue, and 4 5s from the green. So one last time, if I wanted to write this repeated multiplication, all these 5s as a single power, I know the base has to be 5, right? Because it's the number that keeps being multiplied over and over and over and over again. And then if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, same questions as before. So if you were to compare the exponents of the expression with the exponents of the power form, do you see a pattern? So again, I'll make them pop. There's a 3 here, a 2 there, it became a 6. There's a 2 here, a 4 here, it became an 8. And there's a 4 and a 3, and that became a 12. So you want to think about, is there an operation that you could apply to these exponents to somehow get this result? Now, keep in mind, we already used the addition and the subtraction. So if we were multiplying with the same base, we added the exponents. If we were dividing with the same base, we subtracted. So those are off the table. All you're left with then is a multiplication operation or possibly division. Okay, so we're just focusing on like the 4 basic operations. All right, so let's see. Well, if I go 3 times 2, do I get 6? Yeah. If I go 2 times 4, will I get 8? Yes. And let's just verify. 4 times 3, do I get 12? Yes. So do we see a pattern? For sure. You notice that now the exponents are being multiplied together. Then if the bases are the same and you have a power raised to a power, such as like down here, right? So power is being raised to a power, then you're going to multiply the exponents. And this one is known as the power law. So question A, we have base 2 raised to a power of 3 or an exponent of 3, then raised to another exponent of 4. So by the power law, I'm allowed to go 2 to the power of 3 times 4, and I would say that's 2 to the power of 12. And I did want you to evaluate, so we can say or 4096. Question B, throwing in a negative, so we have negative 4 base, it's raised to an exponent of 2, which is raised to another exponent. So that's the same thing as having negative 4 as my base raised to the power of 2 times 3. Well, this would be like having negative 4 raised to the power of 6. Or if you were to evaluate that, you will get 4,096. Side note, total fluke, by the way, that these answers end up being the same value. And reminder, eventually we hope that you can go straight from here to here, and straight from here to here, without necessarily having to show the operation you're applying. Next law, we are looking at a quotient raised to an exponent. So a quotient, if you want to think about it, it's going to be in a fraction format. So you notice I have like 1/2, 5/4. Okay, and the special name for this is power of a quotient law. So same idea with these charts. Take this 1/2, tells you have it 3 times. So we're going to take this expression, rewrite it as repeated multiplication. So I have the base 1/2, and I have that 3 times. All right, well, you'll notice, technically this is in power form, but what I want to show you is if you were to focus on top times top times top, bottom times bottom times bottom. So here, this would be like you actually having 1 to the power of 3, and then on the bottom, 2 times 2 times 2, that would actually be like you having 2 to the power of 3. So actually in hindsight, this part's not really what I wanted to point out to you. So we'll just cross it off. Okay, the next one, 5/4. So I have it 4 times. So that's like 5/4 times 5/4 times 5/4 times 5/4. Okay, this already is in power form, which is why I'm saying cross that off. That's not what I'm trying to show you. But what I want to point out is here, you could write this as like 5 times 5 times 5 times 5. Well, that's the same thing as you showing that you have 5 to the power of 4. And then on the bottom, if you have 4 times 4 times 4 times 4, that's the same thing as you showing you have 4 to the power of 4. All right, so the pattern I'm trying to get you to see on this one is the fact that whatever this exponent is, it actually gets applied to the top, so your numerator, and the bottom, your denominator. Okay, same idea here. This 4 got applied to the 5 and also the 4. So we'll just jump straight into what the law actually tells you. Okay, so the power of the quotient law just means that when you raise a quotient, so think of like a fraction to a power, remember we'll be interchanging power exponent. So this 3, sometimes you hear people say that's the power, some people say it's exponent. But what it tells you, when you raise a quotient to a power, the exponent gets applied to the numerator and the denominator. So that power gets applied to the numerator and denominator. And we're going to try examples after the next law. Okay, we're almost there. Product raised to an exponent. So this one's known as power of a product law. So the expression, I have 2 times 3, and it's raised to a power of 2 and exponent of 2. So I just want to show you in repeated multiplication, what it means. You can think of like this whole thing being your base. So this 2 tells you have that twice. So that's like me having 2 times 3 times 2 times 3. So I'm keeping this whole thing as my base. Okay, so I have it once, I have it twice. Well, you'll notice you could actually drop the brackets here and think of it as just 2 times 3 times 2 times 3. And then if I were to clean this up into separate powers, that's like me saying I have the base 2. So I'll color code this. So I have this number 2 times, and then I have the other base 3, also 2 times. So this expression, where I had everything in the brackets being applied to an exponent or a power of 2, I could actually rewrite as 2 to the power 2 times 3 to the power 2. I'll show you another one. So here, this time we have the base, which is 3 times 5. And it tells me that I have that base 4 times. So I'm going to write that out 4 times. So I'm going to show bracket 3 times 5 times the base 3 times 5 times the base 3 times 5 times the base 3 times 5. So I have the base once, twice, 3 times, 4 times, matches that exponent or that power. Then I'm going to drop the brackets. So that's like having 3 times 5 times 3 times 5 times 3 times 5 times 3 times 5. And then maybe even this time I'll do one more step. Maybe let's collect all the 3's and all the 5's. And now that they're organized, maybe it's easier to see there's 1, 2, 3, 4 3's. So I could write that as a separate power. So I have base 3, and I have it 4 times. And then I'm timesing that by 1, 2, 3, 4 5's. So that's like having 5 to the power of 4. Now, again, this one's a little bit tougher to maybe see the pattern, but what happens if you have a base where you have numbers being multiplied together, and that's all that's happening inside the brackets, hopefully you notice that this exponent actually gets applied to both pieces of your product. So I could take this 2 times 3 to the power 2 and instead say, well, that's like 2 to the power 2 times 3 to the power 2. Right? And this one, well, the 3 and the 5, I could break that up as 3 to the power 4 and 5 to the power 4. So just a side note, I could have something like this. I could have 2 times 3 times 4 times 7 raised to the power of 8. Okay, well, I don't want to write this out 8 times, but by this law, what it tells me is this 8 will get applied to the 2. So I'd have 2 to the power 8. It has to get applied to the 3. So I have 3 to the power 8. It has to also get applied to the base 4. So I have 4 to the power 8. And it has to get applied to the base 7. So I'd have 7 to the power 8. And then depending on the question, most likely you wouldn't actually be calculating that because it would be a huge number. But the purpose is applying the law. And keep in mind, that only works if everything's being multiplied together. Okay, so I'll do one last example here. If I had this, like 2 times 3 and then like plus 4, and it was raised to the power 2, you are not allowed to do this. You can't go, this gets applied to the 2, and then this gets applied to the 3, and then this gets applied to the 4. Okay, that's wrong. You're not allowed to do that because you have an addition operation here. The summary for this one then tells you when you raise a product to a power, so for example, there's a product going on here, you're multiplying, the exponent, keep in mind, you might say exponent power, the exponent gets applied to each factor, right? So again, one more, if I had like 2 times 6, so that's a product, I'm multiplying. If it were raised to the power of 4, then my law tells me the 4 gets applied to the first factor, which is a 2, so we'd say 2 to the power of 4, and it gets applied to the second factor, which is 6. So I could say that's like 6 to the power of 4. Next, some practice examples. So write each as a single power and evaluate. So this time I have a quotient raised to a power or raised to an exponent. So my law tells me this 5 gets applied to the top and the bottom. So this would be like having 2 to the power of 5 over 5 to the power of 5. And then we could evaluate it, and that's like having 32 over 3,125. Question B, so this time I have my quotient, so fraction format. It's raised to a power of 2 or an exponent of 2, which is then raised to another power of 2 or an exponent of 2. So my laws tell me I'm going to multiply these together. So this is like having negative 1 over 3 to the power of, I'll show the work, you don't have to if you don't need to. So I go 2 times 2. So that's like negative 1 over 3 to the power of 4. Okay, so here's a side note. If you have something like this, so a negative fraction, negative 1 over 3, you can write it as the 1 being negative. So it could be like negative 1 over 3, or you can write it where the 3 is negative, so 1 over negative 3. Okay, but often you'll just see it sort of out in front. So reason why I'm telling you this, all three of these represent the exact same value. When I'm going to apply this 4, I'm going to think of the negative being attached to the 1. Okay, so you got to pick for it either to be attached to the 1 or to the 3. By default, I tend to attach it to my numerator. Right, so this is going to get applied to the top, n to the bottom, which means I really have negative 1 to the power 4, right? So there's me attaching the negative to my top over 3 to the power 4. And then I put it in brackets this time. I didn't use brackets here just because of that negative value. And then if I evaluate that, negative 1 to the power 4 will give me positive 1. And then 3 to the power 4, I will get 81. Next example, we have 3 times 7 to the power of 3. So this is our power of a product law. And the law tells me that if all of this is being multiplied together, I'm allowed to apply the 3 to the first factor and to the second. So I could write this as 3 to the power 3 times 7 to the power 3. And then if we evaluated it, so you'll get 27 times 343. And I'll just point out, so this is that, this is that. And if you multiply those numbers together, you would get 9,261. Last example, so I have a negative 2 and a negative 5. Remember, they're in brackets, but it implies in there that there's a multiplication going on. So I have a product, it's raised to an exponent of 4. So remember, the 4 will get applied to the first factor. So that's like negative 2 to the power 4. It'll get applied to the second factor. So that's like 5 to the power 4. Then I'll start to evaluate. So negative 2 to the power 4, you will get positive 16. And then 5 to the power 4, you will get 625. Okay, and then with the brackets, it implies multiplication. So if I multiply those two together, you actually will get 10,000. Our very last law, it deals with when you have a zero exponent. So it just tells you any base raised to the power of 0 is always 1. There is one little tiny thing you have to remember though. We are talking about where the base cannot equal 0. All right, so if you had this 0 to the power 0, we are not going to say that's equal to 1. If at any point you want the proof with that, let me know and I can send you some additional information. So if we look at 3 to the power 0, base is 3, it's not 0, it's raised to the power 0, always 1. If I had a negative base to the power 0, still 1. And then just to throw something new at you, if you didn't even have a number, maybe you had a letter, so a variable, if you raise that variable to the power 0, it still will give you a value of 1. And this is more so where you are headed when you continue with your grade 10 math. So we will focus on the number bases. If you're interested in the proof of why this happens, so for example, if I had 2 to the power 4, that's 16. If I had 2 to the power 3, that's 8. If I had 2 to the power 2, that's 4. 2 to the power 1 is just 2. So you'll notice that there's a pattern, right? So to go from 16 to 8, I could divide by 2, 8 to 4. We could divide by 2, 4 to 2. I'm dividing by 2. So then if I continue this, well, the next power would be 2 to the power 0. And according to my pattern, divide by 2, divide by 2, divide by 2, I would have to take 2 divided by 2. Well, that's going to give me a 1. Okay, so that's why a number base to the power 0 ends up being 1. Okay, so your turn to practice. This one is completing practice for exponents. And this should say 2. Again, check your solutions using the key provided as you continue along. If you get stuck, send me an email, let me know. And then at the end, you're going to identify happy face, neutral face, or sad face. And then we will go on to the next step. Have a wonderful day. Bye.